If you want to learn how to gain insights you can act on and solve business problems with data, all while building a data-driven culture at your organization, sign up for Pragmatic Institute's new course, Data Science for Business Leaders. Find out more at pragmaticinstitute.com/data. Welcome to Data Chats, a podcast by Pragmatic Institute and the Data Incubator, where we tackle data topics and trends with experts, industry leaders, instructors, and alumni. I'm your host, Chris Richardson, and today I'm sitting down with Eric Siegel, founder at Predictive Analytics World and Deep Learning World Conference Series, and author of Predictive Analytics. Eric Siegel is a leading consultant and former Columbia University professor who makes machine learning understandable and captivating. And we're going to talk about a lot of very interesting things, one of which is the deployment crisis that Eric was just telling me about that we're going to dig into, where a lot of machine learning projects will fail before they even launch, and which is obviously not ideal, but something that we are all many organizations dealing with. So we are going to dig into that today in particular. But first, Eric, thank you for joining me today.
It's great to be here, Chris. Thanks.
Let's just start off before we get into the really heavy stuff with a bit more about your background. Could you tell listeners a little bit more about who you are and what kind of experience you have?
Yeah, so I'm a former university professor. I'm now a professor again as a visiting analytics professor at the Darden Business School at University of Virginia. But most of the time I'm a consultant. I'm the founder of the conference series you mentioned, Predictive Analytics World, under the umbrella Machine Learning Week. And, I fell in love with machine learning, the idea of a computer that could learn from data, from experience, from examples, in order to make predictions that apply in new situations that have never yet before been seen, which isn't just cool, it is actually useful, as one might expect. So I always thought that was great. And I fell in love with that, in the academic world. But since 2003, I've been out in the real world as an independent consultant, and doing also a bunch of writing and speaking at conferences and organizing those conferences.
Great. Yeah. Well, there's a lot of stuff I want to dig into. Maybe we could start with what it is that machine learning is capable of now, and maybe what it was when you started and what it will be in the future. I think there's a lot of sort of misconceptions about whether or not, I just watched Westworld, the most recent series from Westworld. So I don't think that's actually happening now where, computers can run the world, but, there's a lot of different takes on what machine learning, predictive analytics actually is. So maybe you could just say a little bit about what it is for you.
Sure. So the full title of my book, Predictive Analytics, serves as an informal definition of the field. And predictive analytics is basically a synonym for machine learning. It's at least a major subset. It's when you're applying it for business problems. So the title of the book is Predictive Analytics, the power to predict who will click, buy, lie, or die. That's the end of the title, but of course it goes on, any kind of outcome or behavior for which there'd be value for the organization to predict in order to render large-scale operations more effective. And those predictions serve on a case-by-case basis, individual targeted operational decisions. So if somebody's likely to buy, then market to them. If this transaction is likely to be fraudulent, then spend the time auditing it as a human fraud auditor. If this applicant for a credit card is likely to default on their payment, then think twice before you grant them an approval on their credit card application. So that's the general gist. And, for those types of business problems that I just sort of surveyed briefly, not that much has changed, relatively speaking, in terms of the core technology in recent decades. The thing that's most new is deep learning, where you have the ability to make a prediction or classification on an individual case that's much more detailed. So the entire signal, every single pixel of a high resolution image for medical classification or for image classification. Is this a picture of a cat or a dog? This capability is actually much more advanced than the kind of thing we often use for doing the sort of business type applications I just mentioned. So in the business type applications, you might use something like a decision tree, which is like a bunch of if-then rules, or log linear regression, which is basically just a weighted sum with a little additional math added onto it. And in those cases, you don't hope to predict extremely accurately in the common sense of the word, right? We don't have a clairvoyance as humans or as computers. Is this customer likely to buy? We don't have high confidence and know, like magic crystal ball, which of these transactions are fraudulent. What we can do is play the odds better. So the value we're getting is by predicting better than guessing. I actually call that the prediction effect in my book. A little prediction goes a long way. Predicting better than guessing, generally more than valuable to drive large scale operations more effectively overall on average. So the bottom line gets served. Whereas with the sort of new types of applications you can do, which might lead to more autonomous driving, assistance for physicians with analyzing and making diagnoses out of medical images. Already we see the ability of speech recognition to improve because it's literally taking the entire signal, all of the bits, the ones and zeros that make up an entire sound segment and saying, hey, what are the words that this person spoke? And those are the kinds of things that both humans and computers can do with high confidence, and they get the answer right most of the time. You don't need magic crystal ball. It's credible. And it's doable. So that advanced capability for certain applications is there because of the increased complexity and advancement of that core machine learning capability. But alluding to your Westworld illusion, I don't know, can you allude to an illusion? I can. We have a lot of hyperbole in the public press these days about the word, using the I word, intelligence, and what does it mean for a computer to be intelligent? And because the advancement is so astounding on a technical level, people are very quickly jumping to where this is headed. I would argue it's not. I would argue it's a philosophical question of what a computer ever could be capable of. But the fact that we're increasing in the capability to perform on something that can be quantitatively measured, and that quantitative measure is increasing, that doesn't mean we're moving down some one-dimensional spectrum towards something at all related to what humans are capable of in general. So my argument is that the term artificial intelligence has a major problem with the term itself is intrinsically anthropomorphic. The word intelligence is always in some way about our own capabilities. And we need to recognize that that's philosophy. I love philosophy, but it needs to stay in its lane.
Yeah, well, let's get down to something very pragmatic, right? That's the whole point of the Pragmatic Institute and the Data Incubator is to say, these are great philosophical debates, but how do we solve problems? And so one of the major problems that we started to talk about is that a lot of great ideas or, potentially great ideas just miss the mark and don't even necessarily get deployed. And if they do, it fails at launch or before launch because of a bunch of things that are going on in organizations. Maybe you could say a little bit about those practical issues first. Yeah. Why do so many great ideas seem to fail in organizations?
Yeah, I've been working on this a bunch, and I ran a survey along with KD Nuggets, which is a major and long-standing analytics newsletter and portal, asking data scientists how many of your projects launch. And to be a little more specific, how many of your models, and that's what machine learning does, it generates a model, and then the model is being used to make these predictions, right? So how many of your models that you generate with the intention of deployment, right, which differentiates it from a research project, you're going to actually use it to improve operations? How many of them actually deploy? And it turns out more than half the respondents said that only between 0 and 20% are getting deployed. And this is backed up with a whole bunch of anecdotal noise that's coming up in the insider press, in the industry news these days, as well as a bit of other research done with surveys in industry research. So in a way, it's not that big of a surprise, because what people tend to do is they tend to underestimate what it takes to get to deployment. So just to put a little context on this, in this part of this conversation, you and I are putting aside the whole AI hype, AI philosophy question. Even if you don't drink one bit of the AI Kool-Aid and you're a senior expert practitioner in machine learning, when you're trying to start a new initiative at your corporation, you're still very liable to make this extremely prevalent mistake that leads to a lack of deployment. And the mistake is that we all, on some level, it's just human nature, we're kind of fetishizing the technology. I mean, of course, the core technology, the ability for the algorithm to derive generalizations from examples, that is, to automatically form the predictive model that then pans out, that does pretty well on situations never before seen. That's really cool. That's really exciting. That's the promise, right? That's the thing that's driving the project in the first place, not to mention all the excitement in industry these days. But the problem is, from an organizational perspective, to make value from that, you need to actually change the most important operations, large scale operations. If they don't change, you haven't done anything to improve what the organization is capable of doing and its performance. The scores, the predictive probabilities output by the model on a case by case basis need to affect that change. They need to be integrated into existing processes. That's not the rocket science part. That's just change management. But we're not calling these projects operational improvement projects that happen to use machine learning. We're calling these projects machine learning projects. And because of that, we're just automatically underestimating what it takes and undervaluing the need for the right kind of proselytizing and socializing of the operational change across the organization outside of the data science department or your cubicle.
Yeah, I mean, you hit on a few really interesting points about who should be in the room, who is in the room in these organizational meetings or changes. And I wonder if you could say more about some of the roles, because I feel like there may be an impression in some places where the C-suite says, we have a lot of money right now. We want to go and be prepared for the future. So we're going to hire the smartest computer engineers or data scientists or a group of people. And yet we still get these horrible numbers, like you just mentioned, right? Like less than 20% of these projects necessarily getting put out and used in the world. Where do people tend to miss the mark, or what groups? And I'm not trying to assign blame, but I wonder, because you just said it may be an organizational issue. It may not be, a technical issue, or maybe it is sometimes a technical issue that gets missed because you could be very smart, but you don't have the resources in an organization. Or where are these gaps tending to be when you look at them or when you dig into that kind of number?
Yeah, it's an organizational problem, not a technical one. There could be technical gotchas that impede deployment, but that's a symptom of an organizational one. But just before I really answer your question, just take a step back. It's not that 20 or fewer % of models are getting deployed. That's what more than half the data scientists said. The other half gave higher numbers. So the average might be 30, 40. The other thing is it's very contextual, because so if the stars are aligned, if you're at one of the big tech and you're improving an existing model that's already deployed to help with, let's say, Google Translate, anyone can go into Google Translate and it translates between languages. It does so extremely well. And it does use a deep learning model to do that. You're bound to succeed. You're going to improve the model and then it will be deployed. Or in general, if you're in a situation where you're improving a model that's already actually been successfully deployed, or if you're within certain regions and sectors where things tend to be done. I mean, all the telecommunications predict which of their customers is going to cancel their cell phone subscription. All of the major financial institutions predict the credit risk, as I mentioned earlier. So you have situations where you're much more likely to succeed. But still, the majority are failing, and that's often because of new initiatives. And also perhaps that result is skewed because a lot of the respondents are just sort of the newcomers who were drawn by deep learning, and that's so new and speculative about how it could actually be deployed. They may be real Einstein brainiacs and create a great model, but that's not the same thing as being positioned within the organization to convince others that it should actually be deployed. So to actually answer your question about what could be done, there's no one size fits all as far as organizational structure. And should this be ordained by the CEO, or should it come from the bottom up from analytics, hands-on experts that have a great idea, or from operations people who want their operation improved? It could come from a combination of those directions. But the point is, whoever's in charge, whoever's making decisions, both on the executive level and where operations are actually being conducted, the operations that are going to have to agreeably be changed, need to be ramped up and brought into the loop so much more than most people on the analytics side recognize. That is to say, they need to know exactly what this project is going to do on a mechanical level. What's it going to predict? So, for example, it's going to predict these customers who've been around for at least 4 months are going to decrease their spend by at least 80% in the next 2 months, right? So all the details of that very particular prediction goal define the analytical process to create this model. The model is not going to be able to predict like a crystal ball, and yet it's still going to predict a lot better than guessing. It's going to put odds on these things, but put odds on what? Whatever that exact prediction goal, like the one I just mentioned, that full detailed definition. It's not the rocket science part, but it's pretty detailed. And then exactly how are those probabilities, those predictive scores, going to be used? How are they going to integrate and mechanically actively change whatever the existing marketing operation or web page behavior or whatever action is going to be taken? What exactly is that? And that needs to be ordained, understood, and not only bought into, but weighed into by all these people across the organization. And then on top of that, they need to be continually involved as the project then, maybe it's been greenlit, but then through the phases of that project, which includes preparing the data, making the model, doing some trial deployment, and then evaluating how well it works. They need to be involved at every stage. They need to understand the arithmetic that goes into that measurement of how well it does. The word accuracy is always thrown around. It's typically the wrong measure. There's other arithmetic they have to sort of ramp up on. So everything I just described, none of that is the rocket science part. None of that is the algorithm that can actually derive the model from data. It's good to get a general gist of that stuff. It's the coolest technology. Why not learn a little bit, get a concrete sense of what this thing looks like under the hood? But you don't really need to learn it that much more than I know about the engine in the hood of my car, right? I mean, I know the general principle of spontaneous combustion, but I don't know where the spark plugs are. And I'm a perfectly fine driver, if I might say so myself, right? But to drive a car, right, I need to know, I have an amazing skill set, right? I know about momentum and friction and rules of the road and expectations of what other drivers are doing and all that kind of stuff. And you need the same thing on a more explicit expert level outside of the hood, but under the roof of the car.
You know, it's funny that you say that about driving, because I used that when I was at Pragmatic making one of the courses. That was one of those stats I found sort of funny, and I think we implemented it in one of our talks. Was something like 80% of people think that they're above average drivers. Mm-hmm. So there's clearly a problem with perception, and not to at all challenge your driving. I've never seen you drive, but I'm sure you're a wonderful driver.
I mean, that's I'm familiar with that, and that's why I have to say, if I might say so myself, if I don't stick my tongue in my cheek, I sound goofy saying I'm a good driver, and I'm a very good driver if I'm really concentrating.
Well, but I wanted to ask about these organizations that they may all think, or 80% of organizations may think, that they are going to use this data to be above average, right? But if everyone is thinking in that way, I wonder what actually separates a great organization when it comes to this kind of predictive analytics versus an organization that may think they're great, but actually, you know, objectively, if you get some measurements, are not doing as well as the average. Like, how do you know that you actually are doing a good job in predictive analytics versus hoping or thinking you are? What are some keys?
Well, it's not that hard to look good without actually being good, but the bottom line measure is pretty straightforward. And that's what's so great about machine learning and supervised learning, where you're learning from labeled examples, where you already know in the training data what the right answers are, is that there's a very concrete measurement of just how well it's predicting. And then, of course, in the sermon that I'm giving today, not just how well it's predicting, but how much it's improving operations according to some business metric, some key performance indicator. Again, it's still just arithmetic. You need to be able to measure just how much better the operations are doing. What's the improved return on the marketing? You know, how many fewer bad debtors are you approving for your credit card? Whatever it is, right? You can measure it. So there's no ambiguity there. But in today's world of hype and excitement, it's kind of easy to gloss over that. Hey, we do this. We can't talk about that because, but look how great our model is and how good the technology is. There's a lot of smart people doing great stuff with technology. It's a little more rare to corner somebody and be able to get them to tell you really what happened in the deployment and how much of an improvement that made. But there's nothing mysterious about it. It's just a matter of disclosure.
Yeah, and I wonder what happens in a lot of these cases, like where it actually drops off. So let's say, I mean, you talked about everyone needing to be on board and supportive of an initiative and to have some key metrics ahead of time, right? So they know what they're measuring, they know what their goal is. But let's say if there's an organization that says, I don't know, we want to decrease churn by 10% by the end of the year, and we want to do it in this way. So they have, clearer goals than I've just mentioned. And then they are able to design something that would hopefully, at least using their data right now, reach that or tell them whether it's possible to reach that. I think a lot of organizations can sort of get to that, or at least people can get on board and say, yeah, let's go for it. I promise to implement what you suggest after you do this research. And yet, like we've just been saying, a lot of these things fall off. Where do they tend to fall off if you start off with a agreement from the top down or bottom up, however you want to view the organization? How come they drop off eventually? Or what are some of the key things that often drop off if people all agree, like, we're going to get behind this project at the beginning? What happens?
Now, that's a great question. That's a great question. I think your intuition is spot on that indeed the majority of these projects, including the ones that fail to deploy, there is consensus on some level. Hey, we know there is an agreed business objective, as the case with any kind of technology. There's got to be some particular value, some exact way that it's going to be used. And unless you're one of the AI Kool-Aid drinkers where you think you can plug the thing in the same way you can onboard a new employee and then just let it run loose and create value, everybody's already doing that. They know there should be a particular business use case for it, and they might get fairly specific. My conjecture here is that, in fact, they need to get a lot more specific, and there needs to be a lot more ramp up from the decision makers and the line of business operations managers and the executives to really get a concrete sense of what this project is for. The core technology is the best, coolest, most advanced, and that's fine. That's true. It's the most potent, the most powerful, at least in potential, type of technology. But that doesn't mean it's intrinsically valuable. And people, this kind of socialization of what it's going to take to deploy it, what that real change will entail and who must greenlight it and the way you mitigate the risks when you make that deployment, this all needs to be so much more heavily indoctrinated and socialized and educated on than most people recognize. Because then, as you're sort of alluding to here, when it comes down to it, the data scientist says, okay, I got the model ready. We're ready to go make this big change. And then all of a sudden, they face the upsetting surprise. And it's typically of the frustration of the data scientist. Let's maybe circle back and rethink, what about this, and skeptical questions. And from there, it's hard to say if there's any one particular thing, but it's a phenomenology, right? It's a whole confluence of factors. And depending on the story, it could be one or more that's more heavily weighted. But yeah, it turns out they didn't quite get it. Or it turns out that they're more risk adverse than even they realized. Or it turns out that they didn't understand the model's going to be better than guessing, but not highly accurate in the conventional sense of the word. They had sort of crystal ball expectations, so there was some mismatch there in terms of expectation management. All of these different kinds of things, right? Or it could turn out, oh, really? That means we need to allocate 3 engineers just to deploy it, to get those scores integrated and have it change which ad pops up on the web page or whatever the project is. Oh, well, I can't afford those 3 engineers. And they hadn't anticipated it and thought through the technical requirements of deployment, because the main focus was on, wouldn't it be great if a model predicted this thing and it predicted it this well, and then it could potentially create this improvement on ad serving or whatever it is. They didn't, that sort of last piece, that last mile, it wasn't thought through, because instead of just looking at it typical change management, project management terms, as a business should with any project, somehow, one way or another, our inadvertent fetishization and fascination and excitement about the technology, corrupted the balanced view of the overall project.
Yeah, that's an excellent point. I'm sure that you've heard about those situations. I know I have, when people were really excited about the prediction, but then didn't really know how, or didn't anticipate for some reason, even though it seems logical in hindsight, that they would have to put resources, to do what the prediction says you ought to do.
Exactly.
So there's that risk, is that you have a great prediction and yet you don't have the resources or the buy-in to do what the prediction suggests. What are some of the other risks that might be involved in terms of using predictive analytics? I mean, we've talked I'm sure we've all seen kind of the worst of it, where somebody, just can't get a credit score because there's some flaw in their, history that keeps flagging in the wrong way, even though they're very rich or something, but it doesn't look rich. They don't look rich on paper, or like there's all these kind of things that if you just add a human to the mix, they often fix some of these things. But there seem to be or the potential for a lot of things to go wrong ethically, legally, morally. What are some of the ones that you would highlight for people starting out a project?
Yeah, I mean, so I've actually delved into ethical concerns quite a bit and published a series of op-eds in Scientific American Blog and San Francisco Chronicle and other places. All of my op-eds are easily accessible at civilrightsdata.com.
Good. We'll put that in the show notes too, by the way.
Cool. So yeah, I mean, so in that case, the problem isn't so much that the model doesn't get deployed, but that it does.
Yeah.
And the things that I've focused on are where, there's a clear risk or infringement to social justice, in particular, treating different groups differently. Mm-hmm. What you just mentioned about, the system is, wrong. So there's a piece of corrupt data and therefore it's mangling. I should have a good credit score, but I have a bad one. That you kind of have to chalk that up to the same kind of stuff that occurs even without machine learning. Right. I mean, you get the wrong piece of data in there and something just doesn't work until you finally get a human on the phone. I mean, that's life, right? I mean, that's not exactly within the realm of problems that come up specifically because machine learning. But with machine learning, the system is rendering potentially very consequential decisions about who gets a job and who gets a loan and which defendant, gets parole or gets bail or how long they stay in prison. And in a nutshell, people throw the word bias around a lot, and it can mean a lot of different things. But one of the main things it means is that there's a difference in false positive rates. So that seems to be the front line of the sort of religious debates around this stuff. There's a famous article in ProPublica called Machine Bias, and that's the one that's most often cited, where it showed that a crime predicting model was twice as likely to falsely flag as high risk, and in this case, high risk of repeating a crime, of being convicted. Not actually, so that's part of the problem, is it's not just whether or not the person will commit a crime, it's whether they'll get arrested, which is not quite the same thing, obviously. And in any case, a black defendant is twice as likely to have a false flag, a false positive, as a white defendant. So to make that clear, because I think very rarely do people actually get concrete and they sort of throw around the words and the concerns. And it's not a question of whether one group is flagged more often than another. And some people might take that up. But the unfortunate fact is that some groups, depending on your belief in the data, probably do commit crime more often than others. And that in and of itself is a concern and shows the state of the world and the result of terrible history. But the front line of the main ethical debate, I think, is about the false flag, which is that among people who are definitely innocent or would be wrongly jailed for a more extended period of time, they're more likely to experience that injustice if they're black than if they're white. So I don't think there's a terribly easy way to argue against that, although people certainly do. And in my opinion, the solution to this issue is to say, hey, let's take this result, this terrible result, and see that it's a reflection of the state of the world. And the only way to approach it is with something analogous to affirmative action, where people in different groups are going to need to be held to different score thresholds. So that can be a big pill to swallow in the debate against the, from the opposing side of this debate, I suppose. But that's where I land on that. I could go on a bit more to explain why, but I'll also just mention another issue is whether the model itself actually makes its decision in part based on a protected class, such as race and gender and ethnicity and national origin and such. Again, this is also a somewhat religious debate, probably a little more fringe. I'd say most people on the liberal sphere and probably most people in data science say, oh, no, that would never fly. Besides, it's illegal. It's not even an issue. But in fact, there are a lot of people who are renowned experts, not just in machine learning specifically, but in machine learning ethics more specifically, who are very much proponents of allowing for models to take those protected classes as a direct input. So the decision is based in part on those protected classes. And it could literally do something like, somebody says, why did I not get approved for this job application? And then you say to the person, well, for one thing, the model penalized your score by 7 points because you're Black. And there are people out there very much arguing in favor of that. And there are cases in other countries and in international situations where they're actually doing it.
And is that to identify bias, like to objectively identify bias, or what do you mean by that?
No, I mean to say, hey, if it's like police profiling, right? Where the police say we never do it and it works, right? People who are proponents of police profiling, I think there's probably a great overlap. These proponents of the same thing. They're saying, well, the data shows that we would do a better job keeping, people in jail who are more likely to be convicted again if we make that decision partly based on their race.
Well, you know what? I think probably a lot of people listening, I would gather, are somewhat aware of the data and ethics questions surrounding things just like that, like law enforcement, medical issues, real estate in some cases, and redlining practices. There's a lot of sort of famous terrain, but a lot of people listening, I think, would be working at places where they may very well say, like, I'm trying to sell more Coca-Cola, or like, I'm trying to get people to subscribe to my phone company's plan and not the competitor. So I'm not involved in a lot of these ethics debates. I wonder, where are there potentially ethical questions where it's not so obvious? So you're not talking about putting people in jail based on their race or ethnicity, but in fact, maybe there are questions about, if you're selling a soft drink and you're using data, here are some things you might want to consider that maybe you didn't. I mean, I think a lot of people are working in what they would call, innocuous terrain, and when it comes to ethics, and yet I'm sure there are some ethical questions they should still be considering, right?
Well, sure, but I mean, if the decision is whether to send somebody a coupon for a free topping on their pizza, it's going to be hard to find a case, although I'm sure somebody could find an example. On the other hand, even if you're just doing marketing, there are places where marketing is a way in which you're increasing people's access just by way of their awareness to certain types of important products, including loans. It could be an ad for a loan, or for the apartment of your dreams, go apply to rent this in this building, or whatever it is. So it's very much applicable in those types of scenarios just as well. But taking a broader step back, I've talked mostly here about ethical concerns where we're concerned with the input to the model, but sometimes the output of the model is actually divulging something by predicting something sensitive. So are you familiar with the story about Target predicting which customer is pregnant?
Yeah, but why don't you say that briefly? I'm sure a lot of people have heard that. I think we even mentioned that in one of our courses, but not everyone has. So please.
So this was a publicity debacle for Target, and it was my fault because
It was your fault.
Yeah, I had
okay. I've heard of this story. I've never heard of the person behind it.
Well, I'm not the person behind it, but I take some of the blame, I suppose. I had Target keynote at our Predictive Analytics World Conference, and that's where the story came. In fact, all the details about the story come entirely and only from his keynote, which is available as a video at predictiveanalyticsworld.com/target. And
wow.
I think he was giving a speech that was basically had mostly been used internally at Target. So during the speech, he said, and we're predicting which customer is pregnant. Now, the popular story, so I told the New York Times. That may have been a mistake of me telling it without couching it. The problem was it had been a year by the or no, it had been a few months by the time I told the New York Times. They asked me, hey, what's new or interesting or different? And I thought of it and I told them, but by then I'd sort of actually turned back into the nerd that I don't want to be, which is that, we're all in our little cubicle and we forget to see the societal context. But in the moment he said it on stage, I turned my head and looked at the rest of the audience behind me because I was sitting on the front side of the room for people's reactions, and everyone had a blank face. And I thought, well, geez, that may not go over so well. But a few months later, when the New York Times called me, the honest fact is I forgot that could be sensitive. And I thought, oh, it's interesting, cool, it can help with marketing. Now, the New York Times author, it was an excerpt from his book, told a story about a teen whose pregnancy was divulged to the father because of the system. I believe that's an urban myth. I believe he fabricated the story for a variety of reasons. One of which is that, in his very article, he makes the point that they don't, and as Target made on stage that day, they didn't go off and let the consumer know that they had been earmarked without unwittingly as being probably pregnant. And the way they did that was they would embed the pregnancy related ads amongst other ads. So it would just look random to the end consumer. So there's no way that father would have looked at this and said, oh my God, they must think my daughter's pregnant. And even if he did, the whole story is so unlikely when you look at it with a skeptical eye. But in any case, it could happen. The thing that's the ethical concern here is that it's not a doctor's office. This is medically sensitive information that can have real consequences in life to your job security and all sorts of things. And it's inside of a marketing department. Now, as I mentioned earlier, it's not a crystal ball and it's not going to be correct for all of the predictions, but it will probably be very highly confident for at least a relatively small number. It could be thousands or tens of thousands of customers that are just so likely based on a confluence of factors to be pregnant that it's put together. So it is, in a sense, divulging it. And now you've got these marketers with that information and they have to handle it with care. And they're not necessarily trained to do that. So that's where there's an issue. And there's plenty of other cases where you've got models that output something that, it sort of ascertains from thin air, or that is to say from otherwise innocuous data, something sensitive, including sexual orientation, race and ethnicity from Facebook likes, and these kinds of things. So in a sense, those are cases maybe where the model predicts too well.
Yeah, well, maybe we could, just say a little bit more about this target example, but expand as well. On one level, it sounds like this is just a wonderful marketing strategy or use of data, because if you can, that's why they did it, right? If you can predict who is pregnant before the competitors, you can market towards them. And then if they start, doing a registry, buying all their sons or daughters' clothes from Target, they may be 18 years of great customers, as the child grows up. Mm-hmm. On the other hand, of course, it is medically sensitive if you're going to divulge, and we can talk about the validity of whether Target actually did or not. But if you were to divulge information like, hey, you may be pregnant, or, you may be having a heart attack in the next 5 years, according to our data, all of these kinds of things are sensitive, but also very valuable for an organization. I wonder how you suggest people think about that within an organization. How do you start to think ethically about value and consequences?
Well, you're asking me a sociological question and I'm just a data nerd, but I'm going to answer it anyway. When you're looking at, for that type of thing, you're looking at, well, what's this thing actually predicting? What's it ascertaining about an individual? And if that could have dire consequences in certain cases, then the word sensitive applies, right? There is discrimination in the world. So sexual orientation that's not been explicitly divulged by an individual could be sensitive to that situation with their coworkers or whatever. So if you're devising a way, now you can always, when you're doing ethics to a certain degree, when you're considering the ethics of a model, of a predictive model, there's a certain degree to which you can draw an analogy to what a human does ethically. So I could look at a friend and look in her shopping cart and see certain lotions and whatever the heck and say, oh, geez, I wonder if she's pregnant, right? And I might even use that information to make a decision about something, whether to invite her to go out drinking or whatever. I don't think there's a big ethical concern there because it's the one-off. The ethical concern comes when you've got an institution systematically doing this to large numbers of people. And where now you've got the handle with care, the sensitivity of this big bucket of data, which in this case is the output of the model, the probabilities, and especially those with the high probability of being pregnant. And they didn't volunteer this information. So it's not rocket science, it's sociological, right?
Yeah. Yeah. And I think a lot of the data scientists working on this would say, or maybe, I don't know, I don't want to speak for all these data scientists, but it seems like they could say, I've developed a model. It's for some reason we found a way to predict whether people are pregnant or whether they have these kinds of health concerns. They didn't divulge that. We weren't asking them about it. And yet I can tell you that there's a correlation between that and who's likely to be our customer 5 years from now. And so, do with it what you will. Should a data scientist kind of objectively, quote unquote, just send that out and let the marketing team or the CEO ultimately make decisions about that? Or do you think there is room for intervention where a data scientist or someone working on the ground level with the data at the input or output or both should be, raising flags or explicitly saying some of the ethical concerns, even though they're not making those decisions about what to do with the data later?
Oh, yeah. I mean, it's like anything else. If there's an ethical problem, it doesn't matter what your role in the organization is. You should speak up. I mean, you can. One thing that helps is considering using a little imagination and saying, "Hey, if this were on national television, would it be a publicity debacle? Would there be shame, or would people be shouting the word shame at you?" Now, ideally, you wouldn't avoid doing something because you're afraid of getting caught. But that imagination can probably help make you realize, oh, wait a minute, maybe there is something risky to individuals, right? So when I say it's not rocket science, it's sociological, that's also to say that this is not a legal question, right? The law is never going to cover every problematic or unethical decision. So there's a humanistic side, and it doesn't matter how much of a technical genius you are or how quote unquote purely technical your role in the organization is, you're still operating on planet Earth within this society, and hopefully you care about people. But therein lies the sort of growing pains of this industry, which is that when you are in the cubicle, so at least figuratively speaking, it's very easy to sort of lose the forest for the trees and just trying to get the technical issues to work, both quantitatively, mathematically, and engineering wise. And you very quickly lose track of, it's strange these days how an ethical misstep is brought to public light in an opportunistic way by a journalist. But at the same time, that journalist has trained himself, and in the case of Target, it was a man, to have a keen eye for this and what they think is going to go over well with their readers. So that was the interface between me even if I had a moment of insight during that keynote presentation, I lost it. I went back into my nerdy mindset. And then it was an interface between me as the nerd, sort of familiar with the technical endeavor of the project to the extent that I was from that presentation, and the New York Times journalist, right, who was looking at this from a very different angle, right? And so it ends up being chaotic, unfortunately for everybody.
Yeah, but I think you hit on something too that I wanted to sort of start wrapping up and thinking about the future. That was a learning moment, I think, for so many people involved in data, people involved in marketing, people involved probably in public relations and journalism, right? That Target scenario just keeps coming up because it was such for lack of a better word, a valuable moment where people realized in a very specific way what the technology was capable of doing and what some of the ethical implications were, where it wasn't so clear before necessarily, or at least not to a huge group of people. What do you think we ought to be thinking about going forward? Or where do you see some of the questions, or where should we focus some of our attention when it comes to looking to data to get value for organizations? Where is that going, or where do you see some of those next debacles or insights or just moments where that's the next thing we should be thinking about or the next thing we should be worrying about potentially?
Yeah, I mean, you're right that the Target story was a first of its kind. I think it was sort of the first big publicity debacle about algorithms in general, right? Where the word algorithm largely refers to machine learning, even though it's a more general word in principle. I would say that overall there's very much a positive side to all this, which is that we have a huge opportunity with the advent of machine learning, because the advent of machine learning is the advent of automating and optimizing more decisions. And in that endeavor, we can double down on a society that tends to only increase a lack of opportunity for certain groups. Or we can say, hey, not only is the quantitative analysis a way to bring to light and examine in a new way the extent to which there's unfairness, it's also, because it's being deployed, a platform on which to actually implement remedies. So that, for example, if you go back to the legal case, you've got judges who are being served a probability. The system is saying, hey, this person's 3 times more likely than average to be rearrested. And then that judge will take that into consideration amongst other things. But that's where you're deploying it. In that case, it's decision support rather than decision automation. The human judge is making the decision. It's being supported by the output of the model. But on the front lines there of that deployment, the judges could be so much more educated as far as the ramifications of the system, the historical inequities that are being reflected by these probabilities, and the actual quantitative result of that, to help give them pause and recognize the degree to which, the race of that defendant, for example, has indirectly but substantially influenced the probability, the risk score that they're looking at. So I think overall we have a big opportunity here.
Yeah. No, I think you're right. And I think those are good scenarios to think about as we move into the future, whether you're somebody who's making decisions about marketing or you're somebody who, literally can be making life or death decisions for certain people. We have that same issue, right? Where how much do we want to rely on these predictive analyses and what can we do or what should we do with them? If people are listening to this and they want to start doing something, let's say in the next day, to just either make improvements in relation to these kinds of things or just to think more critically about these kinds of things, what would you recommend they do to make a change tomorrow that would affect how they use or how they think about predictive analytics?
Well, I think that perhaps a greater proportion of modeling products do have the potential to affect social justice on some level than you may have estimated, but I don't know what the proportion is. I think that this whole machine bias and the difference in false positive rates is something everyone should ramp up on. And I have a few videos on YouTube that get into it in detail. They're, the free YouTube portion of my online course, which doesn't focus on ethics, but has a whole bunch of ethics in it. So there's 3 in particular on machine bias. So that should be easy to find, searching my name, Eric Siegel, and machine bias on YouTube. And they're short. They're like 7 minutes each, but that's enough time over 3 videos to actually get into some of the arithmetic. It's detailed arithmetic. It's not rocket science, but it's pretty elusive, and most even senior practitioners haven't quite thought it through about what exactly this is and what it means and what are the ramifications and how should we interpret this as humans.
Yeah. Yeah, I mean, it's a lot to think about. And yeah, I really appreciate you talking to us today on Data Chats about it. You mentioned YouTube, but I was going to ask you, if people want to know more about you or your work, where else might they want to look?
Sure. From my book, thepredictionbook.com, for my course, machinelearning.courses, and the conference is machinelearningweek.com.
Well, I really, appreciate it, Eric. I think we all listening got a lot out of it, and a lot of scary stuff, but also a lot of positive, potentially really positive stuff can come out of this kind of discussion. I think everyone should be having more discussions like this. And so I want to just thank you for leading the way in some respect for that.
Sure. Yeah. Thanks for the great questions and the great conversation.
I appreciate it very much.